In this video, we're going to explore a little further the notions of base, exponent, and place value, and we're going to make use of our song. If you can regroup, you must regroup, and this is how you'll do it. Base, where base refers to the base. Now, up until now, most of our work has been used in either base 10 or base 8 when we did our little joke about Halloween and Christmas. The base we're going to use today is probably the simplest base of all, and that's base 2. So that will mean that for our discussion, our base is going to be 2. That's how we do it. If you remember, our exponent refers to the number of times the song has been sung. So that's the number of times the song's been sung. And our place value tells us what we get when we raise that base and we sing the song that number of times. So it really literally is a value in terms of how much each of those locations are worth. So let's take a quick look then and see what this looks like with actual objects. The objects we're going to use for this are very familiar by now, at least I hope they are. They're the linking centimeter cubes. So this would be our unit. How many times have we sang the song at this point? Well, we have not sang the song at all. So at this point, our base would still be 2. The number of times we have sang the song would be 0, and this is what it would look like. So let's put this down here so we can kind of build a record of this action. So our base is 2. We'll keep track of that up here. The number of times we have sang the song is 0. So this would be 2 to the 0 power. What does it look like? Well, it looks like our unit cube. And what is the place value? Well, the place value is 1. That's how many we have. When we go to put our next counter down, we can regroup. And if you can regroup, you must regroup. And this is how we'll do it. 2, so we'll build the next place value. So at this point, we have now kept the same base. We have sang the song 1 time. What does it look like? Well, it looks like one of these long things end to end. That'll look kind of familiar. It looks like what we would have expected based on our experience with base 8 and base 10. And what would our place value be? Well, how many counters are there here? There are 2. So our place value is 2. When we have 2 of these, the same process will continue. If you can regroup, which we can now, you must regroup. And this is how we'll do it. 2. You might want to question yourself, what do you think that's going to look like? Remember 2 to the 2nd power? That another way of saying that is 2 squared. So we would expect it to look like a square, and son of a gun, there it is. It looks like a square. So what does it look like? Well, it looks like a square. And what is our place value? Well, let's see. It's 2 of these groups of 2. We can count it. There's 1, 2, 3, 4. Our place value is 4. And we can continue it again. This is going to be our 2 to the 3rd power. And just as we'd expected, it looks like a cube. Remember from our earlier discussion, when we raise something to the 3rd power, typically we say it's that number cubed. So it's 2 cubed. What does it look like? Well, it looks like a big cube. Kind of like the one we started with, but a lot larger. And you will notice that we can now repeat this pattern just like we did earlier with base 10 and base 8. We can put 2 of the 2 to the 3rd powers together like this, and notice what it looks like. Looks just like this one, but larger, doesn't it? So we could continue this pattern quite a ways. Now, the nice thing about base 2 is it lets us demonstrate very quickly just what those patterns might look like and gives us a concrete referent. Now we're going to go a little bit more advanced right now, and we're going to change the bass. So that instead of it being bass 2, we're going to just consider any arbitrary bass of the form bass X. So any arbitrary bass whatsoever. And even before we start, we can see a few things. The first thing is, whatever that bass is, before we sing the song, we're still just going to have one cube. It's going to look like that. This is always going to be our ones place value, no matter what bass we're happening to be in. So this gives us a little bit more information in that x to the 0 power is always going to equal 1, no matter what bass you are in. Again, I know that a lot of you have seen this before in your algebra courses, but this is why. This gives a little bit more information in terms of what's going on. When we group them for the first time, regardless of what bass it is, we can arrange them from end to end. And so what we're going to end up with is a long of length x, and so x to the first power will give us x as our place value. Again, it shouldn't be too surprising, but it's nice to see it laid out like this. If we group x of those together, if you will, you're going to end up with a square that's x by x. And so x to the first power, I guess I should complete this, x to the first power will give us x. X to the second power will give us x times x. Again, everything is what we would expect. It is kind of nice, though, to see it, isn't it? So x to the second power is just another way of saying x times x. I'm using the little dot there to indicate multiplication. That's a fairly standard convention, but in case you don't remember it. When we think about x to the third power, let's see what that might look like. Well, we have our square, that's x in one direction, by x in the other direction, and we have x of those going up and down. So it really is the case that we have x times x times x. So when we start thinking about this little song, again, there's a lot more here to unpack than what we might recognize at first. What I want you to remember, though, is that the bass can be any number whatsoever. And we've been discussing the more common basses, but you'll notice that we could pick any number for the bass whatsoever. And when we do that, there's a kind of a common theme here. That is that the first place value is always going to be 1. The second place value is always going to be equal to the value of the bass. So that's why in bass 10 we see our 10s here and our 1s here. Well, in any bass whatsoever, in bass 7, for example, we would see our 1s here, and we would see our first grouping of 7s here. And this will give you a nice clue also in terms of how to build the higher place values. The next place value would just be whatever the bass is times that value, whatever the bass is times that value times that value. Basses are an extremely important part of later arithmetic, and if we do our job well at this point, by setting up a firm understanding for bass 10 and how it operates, we're going to be helping our students later on when they have to deal with more abstracted notions of bass, exponent, and place value.